Hello everyone and welcome back. So this time we're going over Newton's laws of motion, otherwise known as why you don't sit under a tree and take a nap. At least not an apple tree. Okay, how's that for an apple? I'm pretty happy with that. Kind of a weird bottom. Yeah, I'm a teacher, not an artist. So we're going to be learning about equations of motion and also how those motion equations work for a system of particles. Now we're just be focusing on applications right now. We'll get into everything else next time. So first off, parachutist. He's falling to their doom. But luckily they have a parachute, and that parachute gives some sort of drag. Now you can figure out what the drag force is, and you can figure out what it's proportional to. But how do we figure out if this is enough to keep this parachutist from falling to their doom? They need to slow down to a safe velocity. If they can't, then splat. So, if we know that drag force, how are we going to determine the acceleration or velocity to figure out if they're going to be okay? Are they decelerating? Are they accelerating somehow magically? It's going to depend. Okay, now we got a baggage truck right here, and it tows a cart, which tows another cart. Now, if we know that there's friction, there has to be friction. There's always friction. And so there's going to be frictional force developed at the driving wheels of the truck. And it's pushing back. The wheels are pushing on the ground. Now, one question is that going to be enough force to be able to actually move this luggage? Because, if this is too heavy, it might not be enough. Second, knowing how much frictional force we can pull, how fast could we accelerate? So there's lots of questions there. So we've been working so far, going through acceleration and velocity and position and talking about all of those things when it comes to dynamics. And now we're going to start connecting in forces to all those problems, forces to all of our equations, and really taking it to another level. Now, using a similar thing, could we also figure out what force is applied here? Could we also figure out what force is applied right here? Now, there's lots of different aspects to this equation. The problem is we've figured out how to figure out our forces inside of these rows. We understand how they're connected. We can also understand, well, okay, if this one's going in at a certain rate, how fast is this going to go up? All of that we can figure out. What we haven't really worked out is what is the force in the cable going to be? Is that force going to be too great? Is it going to cause it to snap? You have to figure it out by looking at the forces in here, and you're also going to determine, okay, well, based on that, is the size of the cable enough? For my solid mechanics class, the size of the cable will be determining how much stress it can hold. The size of the cable will be determining how much force it can hold, because we have a certain stress that the material could withstand. There we go. Okay, so with all that in mind, we're going to be jumping into Newton's laws of motion next time and talk about those and why they're important to help us solve these problems. So thank you for listening. Remember, we've been having lots of fun with position and acceleration and velocity, and now we got to bring in force to all of those equations. So I hope this helps you, and I'll see you all next time. Bye-bye.